Hello everyone, today we're going to be talking about Spearman's rank, why we use it and how we calculate it. So the reason we use it is to find relationship between two sets of data. Effectively, it gives us an idea of how correlated two sets of data are. So I'm going to have a go with you. We're going to do the exam question that I sent out to you and hopefully you'll begin to understand it. Now the first thing we're going to do, we're going to rank them 1 to how many there are. Now it doesn't matter if you go highest to lowest or lowest to highest, as long as you do both columns the same. So if you're ranking X from high to low, you've got to make sure you rank Y high to low, otherwise they won't work. And all we're going to do is rank them, in this case 1 to 10. Now the Y column, they've already done it for us, so that's really easy because we can just do this. And then we have to look through our data and make sure we put our rankings correct. And getting the correct rankings like that is our first step. The next step is working out the difference of ranks. So what we won't be doing is 305 take away 4.8. We want to do the difference in ranks. So we can see there that as that's rank 10 and that one's rank 10, the difference is 0, difference squared, 0. And we do that for each of them. Like so. And this column here, the d squared column, this will then give us our number that we need for our Spearman rank formula. So we can see that if we add up this d squared column, it comes to 120. Now that's an important number because that is our sum of d squared. That is our total for the d squared column. Now I've got that, I can very simply use this formula, which is in your fieldwork and research booklet. So all we need to do is 1 take away 6 times the sum of d squared, which we've just figured out is 120, divided by, as you can see, it's n cubed minus n. N is simply the number of pairs that we've got, and we've got 10 pairs. So 10 cubed is 1,000, take away 10 gives us 990. And then once we've figured that out, we very simply do 1, take away the number that we get here. So to 2 decimal places, that is 0.73. And then we simply do 1, take away 0.73 equals 0.27. Now the good thing about Spearman's rank is the number straight away gives us an indication of what the correlation is going to be like. The Spearman's rank number must be between -1 and +1. -1 is a perfect negative correlation, +1 is a perfect positive correlation. So if your answer is lower than -1 or higher than +1, you've done something wrong. 0 would be there's absolutely zero correlation whatsoever. So straight away, just by looking at that number, you'll be able to gauge whether there's going to be some sort of correlation or not. Now, we need to know whether this is a significant correlation or not. So what we do, we have a table. This was the table that was emailed out for you. It looks quite complex, but all we want is one number. And we're going to compare our answer, 0.27, to one of these. Now, the one we want to look for is n. That's the amount of pairs we have. and how confident we need to be. Now, when you do your coursework, you'll be expected to be 95% confident or 99%. However, this question says we only need to be 90% confident or 10% error. So we're going to use this one, the 0.1. Our n is 10. All we have to do is line them up. This is the number that's important to us. And then we take our final number and we compare it. And as we can see, our number is lower than the significant number in this table. That means there is no significant correlation. So our number significantly below the table number. Therefore, we say three things. One, that we accept the null hypothesis. That means there is no significant correlation between that. Now, what we'd want to do then is make it about the geography, because this isn't maths, this isn't stats, it's geography. So we need to bring it back to the geography. Now, in this case, the geography is the amount of waste and the carbon emissions. And therefore, in a 6-marker like this, we would want to say there is no significant correlation between the waste per capita and the amount of CO2 emissions. If, of course, the number was higher, then we do the opposite. We accept that there is correlation between the two variables. So that's it. That's what Spearman's rank does. It looks at how correlated two sets of data are. I want to stress it doesn't show causation. That's another thing that we'll go on to later. We don't know one is causing the other, but there's definitely a correlation between these two variables. How correlated they are, we let the Spearman's rank table decide. That will decide whether there is significant correlation or not. So remember the steps, we rank them, we look for difference, we square that difference. We use the formula that's in the booklet, we then compare it to the table to see if it's correlated. I do also want to stress that you will never get a full question like this in your exam. This is what you'll need to do in your coursework. Exam questions are already partially completed. You'll never have to do it from scratch. And therefore, this is the kind of skill that you need to do in your coursework. The good thing about that is no rush. You're not under time conditions. You can take your time. I'm allowed to help you with that. So don't worry if you are stressing about the stats. But hopefully this video has helped. And we'll be moving on to other maths this week, and I'm sure I'll be doing another video next week. So take care, guys, stay safe, and I'll see you all.